A warm welcome everyone to the presentation of topic Network Service Mesh to address cloud-native 5G telco networking challenges. So myself, Roshini Ratnam, working as networking and connectivity architect at Ericsson, and
my name is Franzen. I'm working as a technology specialist at Ericsson.
So these are the agenda items that we will walk you through today. First is 5G and why cloud native, 5G system architecture and its complexity, major challenging telco requirements and different telco traffic classes, and also scenario of when to use secondary network and how NSM can help, and which will be followed by a demo using network service mesh. Why cloud native for 5G? The main reasons include speed by adapting market changes quickly, scale, microservice architecture allow scalability with telco grade reliability, efficiency by simplifying complex telco network functions, and also increase capacity flexibly when service demands grows. Why Kubernetes? And what do we get from Kubernetes primary networking model? So Kubernetes is a CNCF recommended cloud platform. It provides lifecycle management, scaling and auto healing, service discovery, external service exposure, load balancing. And this is the 5G system architecture based on 3GPP reference. The rectangular boxes represent different network functions that basically does network functions, with most of them being software based. And you also see interfaces between different network functions. So some of the network functions examples are network slice selection function, NSSF, network exposure function, NEF, network repository function, packet policy control function, unified data management, application function, etc. You also see below user equipment, which is mobile, laptop, etc., radio access network, user plane function, and data networks. So the highlighted area, the interfaces in this highlighted area are service-based interfaces. So basically, they can be implemented using Kubernetes primary networking because they are HTTP2 or API-based, so web-based interfaces. So they can be implemented using Kubernetes primary networking. The interfaces highlighted in the below area are non-SBI, non-service-based interfaces. They are telco interfaces over L2, L3. The telco interfaces are with high requirements such as high performance, low jitter, high bandwidth, and not suitable for Kubernetes networking. Example is user data plane traffic between user equipment and data network, which is mostly encapsulated in GTP protocol. So for service-based interfaces, we need to use secondary networks, as Kubernetes network cannot handle them and need different secondary networking solutions such as Multus or network service mesh. So based on all these details, why we are showing this picture in this slide is because to show how complex the architecture is, and also to highlight the challenging requirements that telco has. So based on that, we are outlining the major challenging telco requirements. One of them is operator requirement on end-to-end VPN separation. Due to security or legacy reasons, operators expect end-to-end VPN separation from external network till application ports. With Kubernetes single network model, only external traffic separation is possible and no end-to-end VPN separation. And the second challenging requirement is that support for no NAT protocols. So protocols that are NAT sensitive, like session initiation protocol, SIP, or media. And the third main challenging requirement is egress sweep for outgoing traffic originating from application ports. So outgoing traffic from pod leaves Kubernetes cluster with IP address of worker nodes. The outgoing traffic need to come out with a virtual IP address without NAT. One reason why this is required is the IP address limit, because of too many IPs for outgoing traffic, and customer expects common IP for incoming and outgoing. And another major requirement is support for non-IP protocols. And last but not least, we need to support high performance traffic, that is traffic with low latency, low jitter, high number of packets per second, and high bandwidth. So based on these requirements, there is a need to support different traffic types. So here we outline different telco traffic classes based on different traffic types, characteristics, and packets per second. So first classification is low performance with high functionality. That is, it doesn't require too much latency, so no latency sensitive. It includes protocols that supports protocol level encryption, but the traffic requires services like load balancer, service discovery, VIP address management, etc. And the number of packets per second that needs to handle is like 0 to 1 million packets per second. And example is operation and maintenance protocols like SNMP, NetConf, etc. And the other classification is high performance, low function, which is only at the data link or L2 level. They need to handle high performance user plane or data plane implemented normally using DPDK and SRIOV. The traffic needs to handle 5 million packets per second and more. Example is user plane function, radio access network, etc. There is also a middle category that is medium performance, which lies between these two categories. They include high performance control plane or low performance data plane. And the traffic that needs to handle 1 to 5 million packets per second. Example is diameter, SIP, etc. So with these details, Anders Franzen will show you visualization of when to use secondary network in the next slide. So Anders?
Yep, hello. So we put together a small decision graph on how to decide when to go for a secondary network. Of course, the strive should be to always use a primary network to be as cloud native as possible. So we start with a question saying, can we use a primary network of Kubernetes? And then we say yes. And then, of course, we use the primary network. So this is the easy solution. If, for instance, they will say, no, we cannot use the primary network of Kubernetes. So we think then, why can we not do that? There must be a reason. And the reason might be because of protocols. I mean, Kubernetes is like supporting HTTP and web protocols and stuff like that. And it's not really good at TCP and stuff, but we have a lot of different protocols. So then we can think about, can we change the protocols of the application to instead be web-based or something like that? If we can do that, then we use the primary network. If we cannot change the protocols, then we can see, can we update Kubernetes to actually handle this kind of protocol? Like SCTP is something that has been added quite recently, I think. If we can do that, then we can use primary. If we cannot modify Kubernetes, then we must use a secondary network. Then there's other reasons. For instance, the operator. The operator might decide that we are not allowed to use the primary network for the public access. And that if you look at the previous slides on Roshini, we have this low performance, high functionality network. And that is the Kubernetes primary network will fit into that category as well. But sometimes we are not allowed to use it for security reasons or whatever. So the typical case here is that we are replacing a functionality that is already deployed at an operator. And they have an architecture with a lot of networks already to other operators. So then we cannot just shortcut all the networks that's already out there. We must be able to terminate them. But then we have the question, can we try to migrate the legacy network architecture to a new flat network? If we can do that, we can use the primary. If not, we have to use a secondary network. So the other reason would be just the performance part. If we need to switch more than 5 million packets per second and with no latency, there is actually not much we can do. And if we are latency dependent, then we cannot do much. If we are bandwidth dependent, then we could try to distribute the traffic over multiple workers. So in that case, if we can distribute traffic, we can use the primary network instead. But if we are very latency bound, we cannot do that. Then we have to use a secondary network. So this is some of the reasons when we need to add a secondary network. I forgot. And then we are looking into different, a very common CNI to use at Ericsson is the Multus. Everybody's using it. But we are looking into this network service mesh that is like a part of the CNCF project as well. Network service mesh is a novel approach solving complicated L2, L3 use cases that in Kubernetes are tricky to address with the existing Kubernetes network model. Sounds like perfect what we need actually. And then we can look. Network service mesh maps the concept of a service mesh to L2 and L3 payloads as part of an attempt to architecturally transpose NFV in a cloud-native way to utilize microservice architecture. This sentence is kind of condensed, but you can easily say that we have an network function version, NFV, and we can convert that to a microservice by using NSM more or less, because we can model the network service in a way that fits Kubernetes very good. We can use Helm charts to deploy it and this kind of stuff. So I think that NSM will be good for doing this, to break down the functionality that we have. And NSM is built around a distributed broker to keep track of all the resources and a set of integrated data planes to interconnect the resources in a coordinated way. So we as applications can actually implement a set of services on top of NSM, which NSM will keep track of those services, and we on the other side where we have consumers of this, we can just say that we need we have a dependence on this service, and NSM will connect us to that. So we have a defined API to implement the services I talked about recently. They're like firewalls, load balancer, different external devices. And we have a defined API for an application to consume those services. So then we have a demo, because we have done a couple of POCs with NSM. And this demo, Roshini will show a bit later. I will start here with a logical view of it. What we have is an application, that's the purple box, and that's a pod. And then we have a controller, the controller is like an NSM controller, and what it implements is a load balancing service. And we have another controller that is a front-end VLAN termination service. We have modified NSM a bit here, so we are running with the Linux kernel data plane, or forwarder as it's called nowadays. So the load balancer is actually the IPv, the Linux kernel load balancer. And then we have a cross connect, and we have also broken that, because usually in NSM, the controller and the data handler are like the same container. But here we just control the resources from the NSM pods, and the data path is going through the kernel. So this is not extremely fast, but it's kind of flexible, and we can model our functions. So we will come in to the cluster with the VLAN. We go to cross connect, and then we will use like a VXLAN to reach the load balancing function, and that one will point to multiple application pods. I think next screen will show the more physical realization of this. So we have a Kubernetes cluster. We have 3 nodes, 1 master, 2 workers. We start by having like pods sitting in the worker 1 and worker 2. This pod is a distributed, it's the same function, it's just in 2 places, and that's normal. And that's normal distribution. And then we start adding stuff here. So we add the network service mesh manager. And we add the network service mesh forwarder. This forwarder we have modified ourselves. So then we add the service called the front-end network service endpoint. It's actually the controller sitting in worker 2, but it creates an interface on worker 1 that will go out to the external world. Next step, we add the load balancer network service endpoint. And that one will then be connected, you can see here. So we get a packet coming. It goes to the ETH1, which is associated with the front-end network service endpoint. That one will send the packet to the load balancer. The load balancer will select one of or in this case it selects both, but it will select one at a time, of course. And then we have it. We have the select. I need to go back here again. And then I will leave to Roshini so she can actually show the demo running.
Thank you, Anders. So now we will show the same setup in the live demo. So the external client will be called as a test machine, and I have a master node and two worker nodes. So this is the my master VM, and I will show you the nodes. So you can see I have a master node and two worker nodes. And I will show the ports. So when you install a network service mesh, you will get the control plane, which is the NSM manager, and you get the kernel forwarder. You can choose the kernel forwarder or VPP forwarder based on the available data planes in the network service mesh that you have installed. So here we used a kernel forwarder, and also we did some modification to make use of front-end network service logic. And this SFTP ports are my application ports. So I'm running an SFTP server so that I can test using an SSH from a test machine. So as you see, I have two ports running on two of my worker nodes. And front-end network service endpoint is the network service that, as Anders has explained, that we have designed and added as a plugin on top of network service mesh framework, which will allow us to connect, access a controller and connect to the external network. So load balancer network service is where we have the load balancing functionality, which will do the load balancing of the external traffic to the backend ports. So maybe it's interesting to see the network interfaces of the application port. So when you deploy an application on Kubernetes, ETH0 is the default interface that you receive. In my system, I use Calico as a CNI plugin. So this is the Calico network. And since in the application port, I am requesting a network service endpoint, so that's why I got an additional interface that is NSM, which is actually handled by the network service mesh. Maybe it will be interesting to also see the interfaces of load balancer. So this is my load balancer network service. So as usual, you have the default interface and NSM interface that I received from the network service mesh. And this is the network interfaces towards my application port. And this network service interface is the one that is facing towards the external network. With that, maybe we can try to do a testing from an external client. So this test machine is actually running outside my Kubernetes cluster. So from this test machine, I will try to do SSH towards my application port. So let's try to, so this is the virtual IP that I'm going to use every time. So every time when I try to do SSH, I should get different host name. So here I'm trying to print the host name of the application port. So let's try every time what is the host name that we receive. So each time when we do the SSH, we can see we are getting different host names. So basically, this is the host name of the application port. So this load balancing, it's still using single VIP, and the load balancing is happening behind, and this is being done by the load balancer network service. So maybe it is also interesting to see how in the application that we are requesting the network service endpoint. So this is the deployment manifest. And here you can see that I have an annotation that is pointing, that is requesting to a specific network service. So you can implement your own network service and can deploy it on network service mesh and can refer the network service in this annotation. So this is the only change that you have to do in the application. So if you are using Multus network, Multus solution, you still get additional interfaces, but then the service, the same service discovery and load balancing has to be handled. Here, network service mesh handles everything. From application point of view, you just need to specify which network service you need to use. So with that, I have concluded the demo, and I will stop sharing and we can go back to the slide.
So, thank you, everybody. And if we have some key takeaway from this presentation, that would be that our old telco legacy cannot live with only like the primary web interface network. We actually need a secondary network. And we think NSM is a good way forward because we can model the network as a microservice more or less, I think. What do you say, Roshini?
Yeah, and application-specific network services can also be packaged and can be deployed on network service mesh. And when we go to customer CAS, application doesn't need to request for special privileges because that is being handled by network service mesh itself. And also all the networking solution is handled by network service mesh. So it's kind of a cloud native Kubernetes way that application can just request for the network service, and remaining logic will be handled by network service mesh. So with that, thank you everyone for participating in this presentation.
So,
hello everyone. Thank you for coming. So we have got some interesting questions. So we'll go through them. Shall I read, Anders?
or we can take the first two questions from Marco Antonio Gonzalez Ortiz is about how Kubernetes can handle throughput requirements and SRIOV infra design requirements. I assume the questions are very similar to me. So what can you say? The Kubernetes cannot handle that. You need to have Multus or NSM or something that can provide you with a user mode like networking interface. I think. Well, what do you think, Roshini?
So basically Kubernetes primary networking cannot handle it. That's why we need to have similar kind of solution. It could be Multus with or NSM or any other solution which needs secondary networking, anything outside Kubernetes networking. Okay, so that was first question. Then there was a question from Sergey Ignatiev. Sorry if I pronounce it wrong. Has SCTP been added to Kubernetes CNI? SCTP has been supported by Kubernetes from 1.12 release, if I remember correctly. But then multi-homing scenario is not supported by Kubernetes networking. So that will be a challenge requirement.
And it is the kube proxy that needs to track the sessions. I think it's not the CNI itself. I assume the kube proxy is the yeah.
And there was another question. Will you use VXLAN for 5G CNFs or VLANs?
Now, why did you
it's
okay.
a seventh question.
Yeah, and what we showed here is the POC only. I mean, and our 5G implementations today, I think they use Multus and VLANs, most of them. And this is what we are looking into to make this more model driven. And in our POC that we show, the demo Roshini showed, we use VLANs for the external connection, but internally NSM is using VXLANs for the different streams or say sessions. Yeah. So that's at least what I know. I think that our current implementation in 5G uses VLAN, Multus and VLAN, I think. Do you have any other information, Roshini?
No, I agree what you said. So we can take the next one. Why was Multus not enough for this use case? So this is what we summarized in our key takeaways, that when we have to base our solution on Multus, then the services like load balancing, service discovery, IPAM, and so on, which is handled by Kubernetes networking by itself, has to be implemented as separate services, and it has to be bundled with the application, and you have to carry that in different deployment environments. And some might require special privileges and so on. But when we are using network service mesh, what we need is to have this additional network services that will fulfill the use cases. The remaining whole solution, or the networking, is handled by network service mesh, so which is similar kind of Kubernetes CNCF kind of way. So this is why we think NSM could be like a potential a solution for secondary networking. And having said that, obviously, if you're going to a customer cars and if NSM is installed there, then from like an application doesn't require any special privileges, because that has been already been carried or taken care. Anders, do you have anything more to add?
Yeah, I know that's the same as you're saying, but I think that you can say it very easy. Multus is actually giving you an interface into the pod. And with that, you can do you can do anything in the world with it, but everything will be an ad hoc solution. With NSM, we see it as a possible way to make it model driven and have like a standard way of doing it. So, yeah.
Okay, so next question is, are you using Calico without IP in your demo? Is this running on bare metal with BGP? This is a question from Adel Zaluk. So in our demo, we have been focusing on the secondary networking, and of course our primary networking is using Calico with IP, and this is run on VM machines, so with BGP, of course. But our focus was mostly on the secondary networking. That means a network other than the Kubernetes Calico network. Anders, do you have anything to add?
No, I agree with you. You have your system, and I have different systems. I mean, but we are running Calico.
Yeah. There is another question from Francisco Castello. Is the demo code available? We probably push this changes to, the services we might push towards NSM community. And Anders, maybe we should plan to,
we want to do this because the main thing here is actually the breakout of the front end part, isn't it? And what
exactly.
we made a hack in the forwarder, and what we need to do is to use the new NSM architecture to make our own forwarder, and that we could probably make available. But this code, if we make it available, it has to be made available on the side of the NSM standard repo, because it will not work together with it. Do you understand that?
Yeah.
I mean, we have messed up the NSM original code.
Yeah. Shall we go to the next question?
No.
Okay. It's a question from Killian Muldoon. Is this a better overall solution at scale than Multus-based solution? So the question is about scalability.
And Multus, does it scale? It just gives you an interface per node. So actually, if I say I have a Multus solution, I don't know how that scales, really. I mean, it depends. You will put cables into a switch, but how it's working, I cannot say. And this is the problem with Multus, I think. And Multus is just like a way into the pod. It doesn't say anything of the overall architecture. What do you say, Roshini?
Yeah. So, I mean, if you want to get an additional interface, you can use Multus with additional CNIs. But then there are much more that we need to handle, like the services that will
How
be needed. Yeah.
this is the thing.
Yeah, exactly. So once you got, I mean, an extra interface, that won't be enough. You have to do a bit more. Then that has to be handled within your application code, which is like a bit. I mean, it's a bit more work per each application. Then each application have to do individually, and that will be again a bit different. And here from NSM point of view, from application side, they just need to request for in service in their manifest, like in their deployment manifest. They just need to add an annotation, as we have shown in the demo, to explain like I need a specific network service that will handle load balancing or whatever. Then the rest, everything, the connection and everything is handled by NSM using network services and other mechanisms. But from application point of view, we are kind of no need to worry about what is happening in the background, similar to Kubernetes. So in Kubernetes networking, we don't normally write a load balancing mechanism or service discovery mechanism. It's handled by Kubernetes. So this is something similar that will be done with an NSM framework. It's a framework where you can add network services as a plugins. So which kind of network services you want, that is up to you to write. And so yeah, so for in our example, we have shown like load balancer as a network service and friend end as a network service. I think I talked too much. I should go to next question. It's a question from Adrian Brunder. Do
No,
you
Jeff,
see?
don't have from Jeff Sellens.
Okay, sorry. Yeah.
How are you overcoming challenges of pods that require local affinity due to latency limitation? Yeah, I mean, we have to do pinning like everybody. There's no way around this. I don't know. I mean, I have seen, because we are not come so far yet. I've seen something where you, in Kubernetes, where you can put that you require a number of CPUs and you put the limits the same as the amount you have or something, and then you will more or less. That we need to fix it with C groups or something, but we need to have the process standing on the core, on one core, and the same comes to scaling of the forwarding plane. I don't know that. It has to be done with the application in mind. I mean, we need to find some way of dividing it into sessions or something like this. We cannot just split the stream up. I don't know if that's a good answer. Do you know more, Roshini?
Yeah, I think I have the same answer as well. But if you have more questions, we can get clarified in the Slack channel later. So we will be available for 15 more minutes after the time is over. So next question from Adrian Bronder. Do you see a need for even more networks, or does secondary means just any other kind of network except the primary? It's
No,
the terminology that we are using. Yeah. So
we
as you understood right, it's any
yeah, we
network other than primary networking. So it could be one or more.
or five. Secondary
Yeah.
network is just secondary from Kubernetes sets.
Maybe the terminology we used is wrong, but yeah, so we call it a secondary. Yeah.
No,
Another.
so like, it's a specific network being recommended for the secondary network used by Multus. Yeah, we are looking at NSM, and it's not a CNI at all. But if you want to have a CNI, then it's the Intel DPDK, I mean SRV suite that people are using most. I mean, I think that in our place most people use those as well, the SRV ones for DPDK and what's it called, to get the user mode, the PCI into user mode. Do you know that VFIU or something? Roshini. Yeah.
No,
Yeah.
I'm not sure.
We can. Everybody knows that's into that kind of business.
Okay, so next question from Atul Deshpande. Are you exposing the cluster node to outside world with the public IP in this architecture when external client is connecting to LB NSE? So it was a VIP address, virtual IP, that a routable virtual IP. This is what we were exposing in the demo, and the external client was trying to connect to the VIP. So that's why even though behind we had multiple application ports, we could connect to either of them using the same VIP. So that was the concept that we used. Anders, do you have anything more to add?
No, but this is we've done this different. I mean, you can put the public IP on the load balancer, and then you use NAT to get into the system. Sometimes in Ericsson we actually use the server return, so we use the VIP address on the actual clients as well. So you don't have any NAT, a NAT-less load balancer. And I don't know, in this case I think it's a NAT, isn't it, Roshini? In the example here.
Yeah.
We have example where we run on that as well.
Yeah.
Where we have the VIP address sitting on all the pods. But there is the VIP address with public IP now.
And next question. Some teams say NSM not ready for 5G core. Is it feasible that we deploy 5G core without NSM, then evolve? Is it possible? Yeah. So these network services that we have mentioned has to be developed and designed with telco grade quality, and this is something that has to be initiated, and of course it is possible to evolve from any other solution to NSM. As I mentioned, you just need to have the annotations in your application where you mention which network service that has to be selected, but then this network service needs to be there in the NSM, has to be deployed in the NSM. So this is something that has to be worked on, and yes, it is feasible that you could evolve. Anders, do you have any other opinion?
It's not feasible today, I would say, but otherwise.
Yeah, exactly. Yep.
Are you reading number 20 or?
No, I am trying to maximize my screen. Can you read?
What about NFV and its standards when it comes to NSM and this new model? I don't know that really, because NFV and its standards is more or less just we use NSM to like implement something. Then what packet comes in and out of the protocol handlers, I mean, that of course must be part of the standard, I assume.
Maybe you need to mention who has asked for.
VJ come up.
Okay.
Yeah. Maybe you can specify the question a bit, or I don't know that.
Yeah,
of course, there are many standards in the NFV world.
Okay. So next is from Francisco Castello. Can this be applied in hosted Kubernetes like Google Cloud or Amazon EKS? Yes, I mean in NSM community they have been doing testing with these public clouds as well, as far as my understanding is right, Anders.
What do you say? Or
this, I mean, in community they are doing testing on public clouds as well.
Yeah, what I don't know here, because some of the stuff we are doing still needs to be like the services needs to be have priority or something like this. And maybe what we would like to see is that all the services we really need are like standard components, so they could be like installed in all this environment and be approved by the operators or the owners of the platform. I mean, because I don't think that they will let us come and put the load balancer in the data plane ourselves.
Okay, so we are now 5 minutes past the Q&A allotted time, but we will be available on Slack to KubeCon networking to continue question answers. We got a lot of questions which we couldn't answer in this short time, but thank you everyone once again for attending the session, and we will be available for 15 more minutes in the KubeCon networking Slack channel. Anders, you want to say something?
Yeah, thank you very much. We have a lot of questions still here. I don't know how we can bring those into the Slack channel. But thank you, everyone that comes and listens.